Hi everybody, it's Miss Dupree. In today's lesson, we're going to learn about changing states of matter. You've already learned about the properties and the molecular motion in solids, liquids, and gases, and a little bit about plasma, the fourth state of matter. And you have learned that the motion of the molecules depends on how much energy the molecules have. So solid molecules have the least amount of energy, and they're barely moving at all. They're just vibrating. While gas molecules have the most amount of energy, and they're moving very fast and very far. So changing states of matter is all about changing energy levels, and heat energy is what gives molecules their energy. So the more heat energy that molecules receive, the faster they will move. And you saw that in the demonstration with the different temperatures of water and the food coloring. So if a solid substance receives enough heat energy, so here we've got heat energy being added, then those molecules are going to start moving faster. And if they get moving fast enough, then that solid can change into a liquid. If a liquid loses enough heat energy, so it's losing heat energy, getting cooler, then its molecules are going to slow down, and if they slow down enough, then that liquid can change into a solid. So the change from one state of matter to another state of matter is called a phase change. And every phase change, there's 6 phase changes, and each one has a name. So we're going to look at one phase change at a time. And we're going to use water for the most part as an example, but it is important to realize that all substances can change phase if they gain or lose enough heat energy. So let's start with solid water, which is ice. And we say that ice is frozen water, which it is, but a lot of times we think that the word frozen means really, really cold, because we know that ice is frozen and that's really, really cold. But in science, the word frozen does not mean cold at all. The word frozen means that a substance has lost enough heat energy to harden into its solid form. So for example, a block of metal is frozen because it's in its solid form, even though it's maybe sitting there at room temperature, which really isn't cold at all. Or this styrofoam cup is frozen even if it's holding a hot cup of coffee. The styrofoam cup is not cold, it's frozen into its solid form. Make sense? Okay, so solids have the least amount of heat energy. If a solid receives enough heat energy, its molecules will move faster and it will change into a liquid. And the phase change from solid to liquid is called melting. If a liquid loses enough heat energy, its molecules will slow down and it will change into a solid. The phase change from liquid to solid is called freezing. The amount of heat energy that's required to cause a phase change depends on the substance or the material. So for example, metal, such as iron, requires a lot of heat energy to make those molecules move. And that's why metals are frozen solid at room temperature, while water is liquid at room temperature. Water doesn't require as much heat energy to get those molecules moving fast enough to be a liquid. But for iron, it takes a lot of heat energy, about 1,500 degrees Celsius, for iron molecules to have enough energy to move fast enough to melt into a liquid. Make sense? Okay. If a liquid substance receives enough heat energy, the molecules will start moving really fast and the liquid will turn into a gas. The phase change from liquid to gas is called evaporation, or we also call that boiling. If a gas loses enough heat energy, the molecules slow back down and it will turn back into a liquid. The phase change from gas to liquid is called condensation. So we know that boiling into a gas happens to water, but it can also happen to that iron we were talking about. So we already said iron melts from solid to liquid at about 1,500 degrees Celsius. But at about 2,800 degrees Celsius, those iron molecules will finally have enough energy to be moving quickly enough to change that liquid iron to gas iron. Yes, even iron metal can be a gas. So in this video, here we have a bar of iron that's being heated to really high temperatures, and you can see the steam where that liquid has melted and then immediately gotten hot enough to boil and turn into steam. And you can see that steam coming off of the iron bar. Okay, there are two more phase changes, and these are pretty rare. They don't happen a lot, but they do sometimes happen. The first happens when a solid changes directly into a gas without melting into a liquid first. So this can happen when wind blows across ice, and that wind rubbing against the ice can create enough friction to change the solid ice directly into gas. So the phase change from solid directly into gas is called sublimation. And gases can also be changed directly into a solid without condensing into a liquid first. So this can happen with hot steam in very, very cold sub-zero temperatures. If you see what's happening in this picture, this man's got a boiling cup of water. You can see that steam is turning directly into ice up in the air. So the phase change from gas directly into solid is called deposition. There's your 6 phase changes. So we learned in an earlier lesson that states of matter are a non-characteristic property of matter. In other words, you cannot identify a substance just by looking at its state of matter. But there is an element of states of matter that is a characteristic property of matter, and that is the temperature at which a specific substance changes state. So here's an example. Water freezes at 0 degrees Celsius. That's the freezing point of water. Only water freezes at this temperature. So if you have ice and you add heat, it will start melting at 0 degrees Celsius. So if you think about it, the freezing and melting points of substances are going to be the same, including water. The freezing point of water is 0 degrees, but so is the melting point. Think about it. If it's below 0, if it's frozen and then it warms up, when it gets to 0, it starts melting. But if you put it back into the freezer, it's above 0 temperature, but as it cools down and reaches 0 degrees Celsius, it's going to start freezing. So that 0 degrees Celsius marks that line between melting and freezing, depending on whether it's getting cooler or warmer. But again, only water has a freezing and melting point of 0 degrees. Now the boiling and condensation point of water is 100 degrees Celsius, and it's the same thing. If you have a glass of water and you start heating it on the stove, when it reaches 100 degrees Celsius, it will start to boil. But then if that gas gets away from the heat and it starts cooling down, that when it cools down to 100 degrees Celsius and then moves below that, it's going to start condensing. But the only substances that boils or condenses at 100 degrees Celsius is water. So this is a characteristic property that can be used to identify water. So here's a chart that shows the freezing, melting, and the boiling condensation points of some different substances. So you can see that some substances, such as oxygen, they only require a little bit of heat energy to make those molecules start moving fast enough to turn into gas. So oxygen is already a gas, even at very, very cold temperatures, because they just don't need much heat energy to move fast. But that means that it takes really, really, really cold temperatures to cool oxygen down enough to make those molecules slow down and turn into a liquid. And it takes even colder temperatures to make it freeze. So it's got to get all the way down to negative 183 degrees just to turn it into a liquid. And then it's got to cool all the way down to negative 218 degrees Celsius before it will freeze. Okay, but then you can see other substances such as carbon. Carbon requires a lot of heat energy, and again, that's why it's a solid at room temperature, and it requires a lot of heat energy, 3,550 degrees Celsius, just to get it to melt, and then even more heat energy, 4,827 degrees Celsius, before it can boil into a gas. But again, all substances can freeze into solid, melt into liquid, and boil into gas. It's all about the amount of heat energy required for each material to go through a phase change from solid to liquid to gas. And those phase changes, your freezing point, melting point, boiling point, and condensing points, are characteristic properties of matter, because you can use these temperatures to identify different substances by freezing, melting, or boiling them. Okay, you do not need to memorize the temperatures on this chart, but I do want you to know the freezing and melting points of water, because that's pretty standard in science. In fact, that's the way that they created the Celsius thermometer, was they set Celsius to be 0 to be water's freezing and melting point, and they set the Celsius thermometer for 100 degrees to be evaporation and condensation point for water. So that's a pretty big deal. Okay, that's it for this lesson. You should know all the things on this review slide, and you should have your graphic organizer completely filled out. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.